Hello everyone, so we're still looking at the pH of buffer solutions, and in this example we're asked to, a buffer solution consists of 0.2 molar of ammonia and 0.1 molar of ammonium chloride. We need to determine the pH of this buffer solution given the Kb of ammonia, which is 1.8 times 10 to the negative 5. So let's just remind ourselves what this Kb means. So it means that if NH3 aqueous reacts with water, then the water acts as the acid, the NH3 acts as the base, then the NH3 gets protonated to form ammonium plus OH minus, and this has an associated Kb with it, then equilibrium ionization constant, which is 1.8 times 10 to the negative 5. Alright, so now we can do one or two things. Because we are interested in the pH of the buffer solution, you can again either calculate the POH, so you can say POH and use the basic form of the Henderson-Hasselbalch equation, which is equal to the pKb plus log of the conjugate acid concentration divided by the conjugate base concentration. Alright, or you can go the route of saying that pH is equal to the pKa plus log of the conjugate base divided by the acid's concentration. Alright, but remember, we're given information regarding the equilibrium as written from the base point of view. Alright, so that is what we're given information for. If you want to work in this form, you will need Ka of the acid, so meaning you will need the Ka of NH4+. And of course you can go calculate that using Kw, so you can go say Kw over Kb of ammonia, and then you can plug those values in. You can see if you get the same answer as I do. But I want to go the POH route just to cement that one more time. So let's go calculate the POH. So this is of course then equal to minus log of Kb plus log of our acid. So our acid is NH4+, or you can remind yourself that that will be equal to the ammonium chloride solution concentration. Our base is NH3. Alright, and if we then substitute in values, then we get minus log of 1.8 times 10 to the negative 5 plus log of what's that, so the ammonium chloride is 0.1 and this is 0.20, so this gives me a value of 4.44 and so on. Alright, that's the POH, so that from that we can then calculate the pH, which is equal to 14.00 minus POH, and if you round that you get 9.56, which also makes sense. Should be a basic buffer. You're working with NH3, which is a base, should predominantly which has a larger Kb than it has a K1, has a larger Kb than the NH4 has a Ka. Alright, you should get the same value if we calculate the pH directly. Cool. So that is that for this question. Alright, I'll see you in the next video.